how's it going, everyone? My name is Gregory Harrington, and welcome back to VFX Essentials. Today we're going to talk about Smart Vector, so let's go ahead, jump in, and let's get started. Hey guys, welcome back to VFX Essentials. My name is Gregory Harrington, and today we're talking about Smart Vector. So basically I have a shot right here, and we can see that there is a tattoo on his back. So basically what I want to do for this shot is I want to go ahead and I want to paint out this tattoo, and I basically want to make a skin patch. So basically I'm going to take the skin patch, I'm going to place it on top of our plate, I'm going to add smart vectors to it, and what it's going to do is it's going to make the patch distort and match move to his back, and it will basically look more very realistic to how his muscles are contorting and moving around, just like how the plate is. So let me play this and show you exactly what I'm talking about. So we can see this is the original footage. We can see the muscles moving around. Then we do a clean plate, and we can see that it's distorting and doing its job. And then we can start adding graphics on top of it to basically make our own tattoos. We can also add animated footage to this, which is great for like music videos or something like that. Alright guys, we are inside of Nuke, and we can see I have my original footage right here. So basically what we want to do for our first step is we want to render out our smart vectors. So basically what you do to start that is all you do is you create a smart vector. Go ahead and delete this and just do it from scratch. And we can see after we create our smart vector and we hook our source input into our plate, we can see we automatically get an error which says file name and file knob is not set. Now all that means is we just didn't type a file path for it to render yet. That's really all it is. So I'm going to go ahead and do that really quick. We can see I have a bunch of random stuff in here for this tutorial, but for the one I am rendering, I'm going to go ahead and put in that path, but I'm going to label it version 2. And we can see as soon as I typed in version 2, I get another error, but now it's actually just recognizing the fact that I did not render it yet. So basically just don't worry about this yet, because basically what we're going to do is we're going to render it anyway, which will fix this error. Now if we look up here, the first thing we have is our range, and we can change this from the input to the global to the custom. I recommend always doing your input, because if your global frame range does change for some reason, say your global frame range is a lot shorter than your plate, and then for some reason a client or someone wants to extend it, all of a sudden you don't have those smart vector frames there, and you're just going to have to re-render it anyway. So I recommend always keeping that to input. Our second option right here is vector detail. The default is 0.3, which is somewhat of a low detail, but a lot of times it will actually get the job done. But we might see some sort of stretching or pulling in certain areas, so what we can do is we can increase this to 1, and that will give us a higher detailed render pass. Now if we do go all the way to 1, we have a problem, because when we render this, it's going to take an extremely long time to render. But if we change this to 0.3, it will probably render in half of the time or less. So basically, it's up to you which one you want to try first. You could try the 0.3, which will give you a shorter render time, but when you plug it in, you might see certain problems where your smart vectors aren't working. If you increase it to 1, depending on how long the footage is, you could see upwards of 6 hours or 2 hours, something pretty long. For me, for this shot was about 231 frames, but this was only about 20 to 30 minutes for me, so I didn't mind doing it. So I'm gonna go ahead, so the next thing we need to do is we need to render this. And what you can do is you can output to write, and you can export a write. And you can write it from here. Or you can just, you can not have that checked, and we can actually hit this render button. And after you hit the render button, that's going to render it out for you, and you just gotta have to wait for it to go through. Not sure. Oh, there it is. So I'm gonna go ahead and click cancel because I already rendered this off. So basically I rendered off, sorry, I'm not exactly sure what that error was, but I'm guessing it's just because I hit cancel. But anyway, so I actually rendered off 2 different versions. This is a low res version, and this is a high res version. So this one has 0.3 for this vector detail right here, and then the high res has a vector detail of 1. So if we look at these, we can see that it's completely black. So how does this have information? Well, in order for us to actually look at our smart vector passes, we need to go over here on our viewer and change this from RGBA and change it to smart vector. Now we can see this, and a lot of crazy stuff is happening. I mean, really, we can barely tell what's actually happening, but this is basically the smart vector calculating all of the motion that's happening in your plate. So let's go ahead, and this is the low res, and this is the high res, and we can see that the low res has less detail than the high res if you A/B it. So let's go ahead and switch this back to RGBA, and the next thing we can do is, after we have this render, is we can create a vector distort. So I'll just go ahead and create one from scratch. And what we want to do is we want to take our source and our smart vector, and then this is our reference frame right here. So when I look at my footage, and you want to, basically when you look at your footage and you want to find your reference frame, you want to find the flattest part. So I could use maybe frame 3, maybe 58, 120, which is what I actually used for this demonstration. And it really just matters where the image is the flattest at. So I'm going to go ahead and switch this to 120. And we also have an option here which is hold frame. Basically what the hold frame does is it basically just holds the frame from inside the source. So basically what this button is equivalent to is having a frame hold right here, and having it on your reference frame right here. So if I had this unchecked, if I had this frame hold right here, this would be the exact same thing. But it would only be the same on the reference frame, so it's important to note. The second thing is the frame distance. I actually forgot what the frame distance is. I should have reviewed it before I did this, but I believe when the frames get really far away from the reference frame, I believe you want to, let's see. So basically you just adjust this for when you have really, really long shots. So basically if you have like a shot that's less than 100 frames, 0 is absolutely fine. If you have it more, you want to start increasing it. I believe it goes to 6. And basically that'll help your warping. So we have lifetime, that's just your input. We have some filters here. And we have output. And this is pretty important. And I'll go ahead and show you this in a second, but first let me go ahead and show you. So basically the first thing I did for this was I grabbed the original footage, I added a frame hold, and then I added a rotopaint. And with the rotopaint, I basically just I painted out the tattoo, but I tried to also get the shape of the muscle as much as I thought of at the time, and basically just rebuild it as if the tattoo was never there. So the next thing I did was I masked it out. And see, I just made a roto. I made this shape right here. I blurred it a little bit, just like that. I then made a merge mask, and then that just gives me this right here. Please ignore these for right now. I'll show you these in a second. So we still have our clean patch. Let's just disable that for a second. And basically I have two match moves right here, ST map and a smart vector match move. And I'm going to show you this in a second, but let's go ahead and start with this. So this is what I was just talking about earlier. This is the vector distort, and my source is that clean patch I just did for the skin. It's just a frame hold on your reference frame, which is very important. Always do your paint work on your reference frame, and then you hook it into source, and you also hook in your smart vector into the smart vector input of your vector distort. It's a lot of words right there with vector. But anyway, after I did that, I took a, sorry, I'm lagging a little bit. I took the alpha of the guy right here, and I masked it out just to make sure my patch doesn't go outside that boundary, and then I merge it over. So now I have a clean patch with the smart vector attached to it, and as we start moving, we can see the muscles are being moved and distorted with that patch. And just because my computer is lagging a little bit, I'm gonna go ahead and go to my clean plate render just so you can see it better. So we can see we're starting to get the distortion. It's probably not the best area though for an example. Yeah, Smart Vector is somewhat of a heavy node to use, so it does cause a bit of having heavy scripts and things like that. But basically, you can see we're getting that distortion in there, and that looks pretty real to me. So now that we have a clean plate, we can now start doing things like going ahead and adding in our tattoos. So this is the first tattoo I got. Basically, this is something I got from a website called Pixabay. Pixabay.com. They offer some free images, and I found some tattoo artwork that I could use for this demonstration. So this is an image. It's just pure black with an alpha of the wings. So I used their alpha. I made my own constant, and I pre-multed it, and I gave it like a blue ink sort of color. I blurred it a bit for effect, and if we look down here, back where I merged it over, and say I didn't create these parts just yet, we can see my placement is off. So the first thing I actually did was I transformed and scaled it down. I then corner pinned it to move it into place, and I did that mostly because I noticed that this side was a bit larger in perspective than this side, so I just wanted to shift it a little bit. I then I added a grid warp to distort it in such a way that it's more spherical cylinder, because it's we're basically seeing his back and his rib cage, and that's more of a cylindrical shape. So I then merged it over my clean plate. Again, vector distort with my smart vector, and then just merged right over. You can see this is actually really easy. The only actual hard part to this is just the rendering, and it just takes a little bit to do. So with saying how I was talking about how the vector distort takes a little while to work, like it's pretty heavy. Another thing we can do is we can render out an ST map from our vector, or our smart vector, excuse me, or our vector distort. So basically, how you would do this is just right under your smart vector pass, you would create a vector distort, and we have these options right here. Oh, I'm sorry, I forgot to mention one thing. With our vector distort and Nuke 11, we now have this option right here, which is blur size. So we can actually blur our smart vectors in the distortion to basically give a better, more smooth warping than we used to be able to. And it's another workaround is what you used to be able to do anyway before Nuke 11 is you could render out an ST map, which looks like this, and it wouldn't have this blur size right here, but you would basically just select this output ST map, and then after you do that, you're now seeing an ST map right here. Now what you could do is you could actually create an ST map node, and you could actually just hook it up to your vector distort, and this could now be your new match move. But seeing how this is converting your smart vectors to an ST map within this node, it's pretty slow. So what we're going to do instead is we're just going to create a write node and just simply render it off somewhere. Just go ahead and render this off, and again, that's output ST map, just create a write node, name it however you wish, and then just render that off, and that will give you something like this. Now when we have an ST map, we can also add a blur to it. We can see I have a blur here with a size of 32. And over here on my vector distort, we see blur size 32. So now what that means is, if I look at my vector distort, this might take a second because my computer's chugging right now. And we can see we're on frame 82, so this is like the distorted match moved area. And then I look at my ST map, zoom in, I'll switch back and forth. So this is smart vector, ST map. You can see they're the same thing. But let me go ahead and disable this blur node. This is the ST map without the blur node. And now this is the smart vector, or smart distort, with the blur size at 32. So if I turn it off, we can see, and it's actually the same thing. And we can see that the smart distort, vector distort, didn't do a good job on this frame, which is exactly why I blurred it to 32. And basically after I blurred it to 32, I then played the entire thing to make sure that it was distorting correctly with the footage. And I liked what I saw, so I kept it. But basically, since vector distort's a lot slower, we can render off an ST map, we can blur it, and then use an ST map node to do exactly the same exact thing. And that will cut down on your caching process. Alright, so now I'm going to go ahead and move away from this, and I'm going to show you just something a little bit more cool. So another thing you can do is, with our write node, is in our vector distort, we can do something with the ST map inverse. So with the ST map inverse, basically it's the same thing as the ST map, except everything's inversed. Now you're probably wondering, like, okay, what does that do? It's inversed. How's that usable? Well, what you can do is, well, first off, you would render it off just like normal. Make sure to rename it differently from your ST map, like name it ST map inverse or so forth. But what you can do with this is you can actually stabilize your plate. So I have a setup right here. You can see we have our original plate again. And then I have my inversed ST map. I then put the blur in, blur 32, because that's what my match move is set to. I then, I'm just going to go to 120, which is our reference frame. I then plugged in an ST map node. And with the ST map node, you can see you have a couple different settings here. But basically what you want to do is, I believe you want to change this to RGB. Let's just check really quick. So we have our source and our ST map. We can see nothing's really happening with the ST map on default. But if we change the UV channels to RGB, and then we start scrolling in here, and we can see something's happening. This tattoo is staying in exactly the same place as the reference frame. So let me go ahead and see if I can get some of this cached. You can see this is playing, and the tattoo itself is not even moving. Pretty cool, right? So basically this gives us a few options right here. When you have a stabilized plate, you can start doing something, you can basically start rotopainting, but doing it live without having a frame hold on it. So basically, that's what I did right here. As soon as it loads up. So we can see I have the rotopaint. I basically just copy pasted this from my other setup on the frame hold, and I put it right here. And then I'm going to show you a little trick with this rotopaint node. So say you have a rotopaint, you paint it out, and then if we click on this arrow right here, and we click output mask, we basically check this. Like this is default, and this would be to none. This is default setting right here. So you would click this arrow, go to output mask. You would, oh excuse me, you don't actually check that. You hit RGBA alpha. This becomes checked. If we look at our rotopaint node now, we can see we have an alpha for what we just painted. Now, a thing with rotopainting that you need to be aware of is when you rotopaint, sometimes you turn the opacity down, which is fine, but what you want to do is when you're grading, or when you want to create a mask for this, you want it to be 1:1 when you merge it back over. So basically what I'm doing here is we have the alpha right here, and in certain areas around the edges they're not a complete 1. So basically what I did was I took this grade and I changed this to alpha, and I scrubbed down the white point of it, which now gives me more of a 1, more of a selection around here. I then pre-multed it, and that gives me this type of patch. You can see if I didn't grade it, it would be a bit mushier, and you might start getting some weird lines around where I rotopainted. So I did this. We can also do something like we can add an edge blur to it. And that should soften it up a little bit. But anyway, after you do that, you can then rematch move it in. So we have our patch, and we have it painted on a stabilized plate, and your clone stamping is grabbing the information from your stabilized plate. So after you do that, you need to rematch move it in. So basically you take your ST map, not the inverse, just the regular ST map that you rendered earlier, add the same thing, just the size 32, and another ST map with the UV channels at RGB, and then that would rematch move it in. And then I have the, just the key to make sure my patch stays within the boundary of his body. And I'm going to go ahead and show you 2 examples. So this is the paint out we just did of it being stabilized, painting on top of it, and rematch moving it in. And basically when we see that, we can see that there's some lighting changes and things like that. And although this paint job that I did for this isn't very perfect, some weird shapes happening in there, we can see that the muscles are interacting with the light. So this can give you a realistic effect. But also, like with the frame hold paint that I also did earlier, where I'm just painting on frame 120, we can see it's doing a pretty good job, and I was pretty happy with that. But when you have more complicated shots, something where you just can't simply frame hold it and just paint on top of it, the live painting workflow might do a much better job for you. It might be more of a pain, more time consuming, but you might get really, really good results with that. So this tutorial was pretty long. I wasn't expecting it so long. I'm sorry I kind of took a long time to describe certain things and things like that, but I hope you enjoyed it. I'm going to go ahead and skip the checkerboard thing I was talking about, because I think I already explained that. I think everyone gets an idea of what I was talking about at the beginning of the tutorial. Excuse me, my voice is cutting out now. But anyway, this is the end of my tutorial. Thanks guys for watching. I really hope this was beneficial for you guys. Again, what we talked about is clean plating, rendering out smart vectors, rendering out ST maps, rendering out inverse ST maps to stabilize your footage, and also just using different types of graphics to put tattoos over this footage. So another example of some good examples of some things to use with Smart Vector is basically, say you have an actor or actress with a shirt that has like these wrinkles that are moving around. And basically your task is to add some blood to the shirt. You can add the blood to the shirt, and basically with smart vectors is your blood element will start waving and wrinkling with that shirt. Some other things are sometimes actors, actresses, they might touch something, like get some mud on their hands, get some blood on their hands, fake blood, like during the movie, and you might have to remove it because it just happened accidentally, no one caught it, and it doesn't play well for what's happening in the movie. So they need a VFX guy to basically remove it for them. That's where this can come in. This can come in for basically anything that you want to smooth out or remove on the skin or clothing. And that's about it. That's all I wanted to talk about. I hope you guys enjoyed it. Please like and subscribe. Sorry it was lengthy, and see you guys next time.